One. Okay, guys, welcome back to another Tic Tac episode in the Tic Tac Toe series where we're going to build Tic Tac Toe from scratch, obviously, as a command line program. We might move on to build a graphical user interface sometime later. Once we're finished with all this, once we get down some fundamentals, don't have to explain everything, right? Of course, you can just go ahead and do it yourself if you feel like it. Just hit me up on Discord or anything, and we can start talking about ideas and all that. Okay, so now we just have to implement some subroutines from our kind of architectural view. We started with like some large problem and we started breaking it down into smaller and smaller subproblems. Now we have our subproblems. Some of them can be broken down some more, like make a move. If we think about it, to make a move, we have to get user input. We have to parse the user input, which is take the user input, extract the data we need from the user input, make sure it's nice and simple, and we can actually use that data because from the console we'll have like a string, so we have to parse it into an integer or anything, but we'll get to that. And of course, subroutine, function, procedure, just a bunch of statements of code that execute, and we can give them a name, right? And we call them using parentheses where we give our parameters. So just essentially just right here we have sub, the subroutine, the name, and then these parentheses show where we'll put our parameters. If you're familiar with functions in maths, you'll know like if we have a function f, it'll take some variable, we can call it x, and then it'll do something with x, like it'll return x plus 1. And whenever whatever we give for x, like let's say f of 3, it'll just get substituted wherever we see x. And that's essentially what parameters would be. So maybe sub main would take like our arguments or something, and we can use that in the subroutine. Okay, now let's get right into it. So I just have an ID, so it's gonna use those nice features automatically. Just give us a blanket implementation, which really is no implementation. We can talk about exceptions another day, private, public. Of course, if you want to hear more about that, then you should definitely leave that in the comments somewhere. So Initialize Game is just going to set everything back to its initial state, right? So what does that mean? For the board, we want an empty board when we start a game. We want game over to be false. We want current player. Well, we'll see what we do with current player. We'll do something interesting. And then we want our winner to be empty, or there should be no winner. We just started the game, right? So let's just write that out. Var equals 0 to 8. Board I is equal to empty. Right, so we're going from 0 to 8. Areas are indexed from 0, and 8 is the maximum index because we have 9 things. Like if I just draw it out, so this will be our tic-tac-toe board. And if we start counting from 0, this will be 1, this will be 2, 3, 4, 5, 6, 7, and then 8. So if I say board, I'll just use B board like 4, I'm referring to this cell over here. I'm referring to, this is, for now we'll just call this row 1, row 2, row 3. This is column 1, column 2, column 3. So when I say B4, I mean row 2, column 2. Of course, you should start thinking about how we're going to access the board, because right now we have a linear array, right? It's not a two-dimensional array, right? We just have a linear array, 0, that's going to be cell 0, all the way up to cell 8, right? And our user is preferably going to give us like a row where they want to play and then a column. and it's our job to transform that row and column into where they actually want to play in our board, in our internal representation of our board. But we'll get to that. Maybe just something for you to think about, like maybe how 2 plus 2 is 4, but that's not really how we do it. Just something for you to think about. 2 plus 2 is 4. Yeah, yeah. Sorry if there's any noise in the background. Okay, so now going back to it, we're just gonna, we emptied out our board. Game over should be set to false because we just started the game. It can't already be over. Our winner is just gonna be empty, right? We don't have a winning character. We don't have a winning player. And with our current player, let's try doing something interesting by setting it to a random player, right? We want to pick a random player between X and O each time. So we'll generate a random number. Let's say 0 or 1. We'll generate 0 or 1 randomly. And if it's 0, then that means O. If it's 1, that means X is our current player. So now, how do we generate a random number? Thankfully, because we have a standard library, a library just has a set of like functions, classes, all that good stuff to actually make our program, to actually add features to our program without rewriting them every single time in every single program. So we can get a pseudo random number generator, and it's called pseudo because it's not really random, right? Because computers are deterministic. You give a computer some input and you tell it to do the exact same instructions, it's going to give you the same output every single time. So we can't really get some randomness out of them, but there are certain algorithms that that get pretty close, that make it look, that give you random numbers get based on a seed value. Like, in Minecraft, if you want to generate a specific map every single time, you feed it a specific seed. And the pseudo random number generator will use that seed to generate your random map, right? So, either way, how we do this in a Visual Basic anyway, I'm just calling it rand because it's our random object. We can, let's not dwell on the syntax, right? I'm just creating this variable. It's going to be our random number generator, okay? And the way we get a random number out of this guy is by calling rand dot next and then providing the upper limit. So this is like the upper bound, and it doesn't include it. So it's generating numbers from 0 to our upper bound, but not including our upper bound. So we only get 0 or 1 out of here. Okay? We only get 0, 1. So now if our choice is equal to 0, then current player is equal to player O. And since there are only 2 options here, I can just use an else, because if it's not 0, then it has to be 1, right? So then current player will be equal to player X. And look at that. We are essentially done with initializing the game. I don't really have a handle for how long these videos should be, right? Because we can essentially crack this all out in one video. But let's just do make move and then see where life takes us from there. So sub make move. So let's just go over what make move's gonna have to do, okay? So we're gonna assume that the player inputs something in the form like 2 comma 3 for their play, which means which would mean, sorry, which would mean column 2 row 3. like XY essentially. We have anything like this. I feel like that's too much. We have our board like this. Once again, so these are the rows. Row 1, row 2, row 3, column 1, column 2, column 3. And if our player gives us input like column 2, row 3, column 2, row 3, we have to play the current player in this spot. So that would be, X or O, depending on who the current player is. So we have to get user input, parse it because, it's going to be a string. It's going to come in as a string. And now we have to extract the 2 and 3, ignoring the comma because that's just for their convenience. I don't want to write 2 space 3. I don't want to write 2 enter 3 enter. So let's just make it nice by writing 2 comma 3. And then we're gonna have to parse that ourselves. And then once we write that, we have to figure out where it's going to be inside this linear board, right? So yeah, let's get on to that. Let's get on to that. So initially we're just gonna write like a little prompt, like where something, enter your move, and then we'll just say in the form row comma, no, sorry, it's always backwards, row column comma row comma row, e.g. 2 comma 3, just so they know what they're supposed to play. Oh, and I left this out because I wanted to do something called string interpolation, which is just a fancy way of saying that at runtime it's just going to put the value of current player in the string, which is, let's just see what the equivalent would be. We'd say player for the space plus current player plus, like, we'd have to manually concatenate the strings, and sometimes that's okay, but like it would just make the line look longer in this example. And maybe just trying to learn something new every day, right? So you put a $sign in front of your string, and then you can use variables in here. You could even like call functions in here, execute like statements like 1 plus 1, but just, so this will say like player O, enter your move in the form, blah blah blah, right? So just now we need to get this move from the console. Okay, so now we've got the move from the console, and let's just assume that it's in the form 2 comma 3, no spaces, no nothing. Let's just, so there's a column. Sorry, those are my dogs. And they're want me to open the door. I'll just be back. Smarty, I swear to God. Okay, and we're back. Right. Okay. So now we have the player's move. It's in the form column row. It's in the form column row. And now we have to extract the column as an integer, the row as an integer, right? So given that these numbers are only a single digit and we're assuming no spaces, of course we'll move on to a more robust version of this later. We're just trying to simplify things right now. So what we can do is get the first character in the move, and then parse that as an integer, right? And then we can also get the last character in the move and parse that as an integer. And that'll be our column and row, right? So dim call as integer, which is equal to move. Now you can index into strings. Strings are essentially just arrays of characters, right? But of course, we get an error because chars cannot be converted to integers. So now we have some ways of doing that. We can call integer.parse, and that essentially that will just parse it as an integer. It gives us the integer representation. And we have dim row, and then we have the row, and we parse. Well, we are assuming that there are no spaces. There's only a single comma between them, and each number just takes up one character. So if that's the first thing, that's 0, 1, 2. So move 2 should be our row. And now we have to play at that position of the board, right? Now we just have to actually play at the position of that board. Okay. And we'll have to convert like this row and column into an index into our board. So let's just think about that for a second, right? I always put too many. That's not straight. Okay. Right. So imagine you want to play in the middle here. That's 0, 1, 2, 3, 4, 5, 6, 7, 8. It's a 6. That's row 1, row 2, row 3, column 1, column 2, column 3. So we have to get from 4. You play 2, 2, right? But let's actually not use column 1, column 2, column 3. Let's use 0 indexing. So we'll have column 0, column 1, row 0, row 1, row 2, so on and so forth, right? That's just so we'll have row 0, row 1, row 2, column 0, column 1, column 2. Just simplifies the math. So essentially how we're going to do this is we're going to take the row, and then multiply it by 3. Multiply it by 3. Now what does that do? Let's see. It essentially just puts us in this first slot over here. 0 times 3 is still 0, so we're on this first row. 1 times 3 puts us here. This is the index 3 in the array. 2 times 3 puts us here at 6. And then we're going to add on the column. So we take row times 3, that puts us here. And then we add on the column. So if the column's 1, if we place column 1 row 0, it's going to put us here, and then we're going to add on 1, and we're going to be over here. We add on 2, it's going to put us here. We play 2 0. We play a row 2 column 2. 2 times 3 6. 6 plus 2 is 8. And we're exactly where we want it to be, right? That seems like it's gonna work. But then you have to remember that the row and column that the user inputs are not gonna be like starting from 0. They're gonna start from 1, 2, 3. So an easy fix of that is when we get our input, we just subtract 1. Right? The user is gonna input like 1, like 2, 3, for example. This is going to input 2, 3. So column 2, row 3. And when we parse that, we're going to subtract 1. So we're going to store our column here as 1 and our row as 2. And then using the same calculation, 2, 3. This is column 2, row 3. They want to place 7. And then here it'll play 2 times 3, which is 6. 6 plus 1, 7. We get to the exact same spot in the board. Sorry, I didn't mean to exactly erase all that, but anyway. So now we can, it's a simple row times 3 plus col is equal to current player. And now once we've actually set we've actually played the move for the current player, we have to swap over to the next player, right? Now we can, the simplest way to do this is just to use an if statement. Current player is equal to player O, and then we just set current player equal to player X. Else current player equals player O. Okay, what happening here? We got the move, we parsed it out, and then we set the specific cell in our array to the current player. Again, using that like calculation, row times 3 plus col.
Though I'm hopeful, yes I am hopeful for today. Take this music and use it, let it take you away.